आपका पिछली बार आर्टिफिशियल इंटेलिजेंस, मशीन लर्निंग और डीप लर्निंग में कंपैरिजन किया गया था, राइट? आप कंफर्म कर दो एक बार कहाँ तक हम लोग पहुंचे थे। क्या कुछ टॉपिक जो मैंने देखा था, दैट इज दैट वन। यस सर, लोग बोल रहे हैं। ओके, ऑलराइट। ठीक है, तो थोड़ा सा आगे बढ़ते हैं मशीन लर्निंग के टॉपिक पे ही। ऑलराइट। तो बिफोर डूइंग द मशीन लर्निंग हमें कुछ चीज़ें मालूम होनी चाहिए, जैसे कि फॉर एग्जांपल मीन, मीडियन, मोड। कुछ टर्म्स के बारे में हमको पहले मालूम होना चाहिए, राइट? तो वही कुछ टर्म्स पहले हम लोग मशीन लर्निंग को मूव करने से पहले वहाँ पे मूव कर। फॉर एग्जांपल, okay, I'm sharing the screen now. uh, Hope all of you can see the screen, right? All right, mean, median, mode. Hmm. Mean, median, mode. So basically, what is mean? If we talk about the mean, तो मीन क्या होता है? मीन की अगर बात करें, मीन इज द एवरेज, राइट? अगर आपके पास बहुत सारा डेटा है, 21, लाइक 21, 22, 23 till 25, or whatever you can say. Suppose you have six numbers. तो how will find the mean? इन सबको प्लस करके divided by 6, the number of element, right? That will be the mean. Okay, median. What is median? Does anybody know what is median? So please speak in English. I didn't understand Hindi. And middle most value is the, okay. Okay, middle number from the list. That is correct. All right, all right. So we can say that median. What is median? Median is like the middle value, right? So in median, what we will do, for example, how to find the median? Hmm. Suppose you have some numbers like 21, 25, 26, 28, right? So here, what you will do, you first will find the number of elements you have, like 5, and then you will find the middle value. You can divide it with a 2, so you will get 2.5. Basically, it is odd number, so odd number, so it is easy to find out the middle value. So this will be our median, right? So it's very easy to find out. There is one more benefit of using the median is that using the median over the mean is that suppose this your value is very big, right? If you do the mean of these values, you might get because value, right? So you might, for example, suppose you will get 2000 as a mean. Okay. Uh, if you do the mean of these, manage outlier is in, yes, correct. So to manage the outlier, to fix the outlier, we use the median. So mean is 2000, but if you really want to see the values, you can do the median of this, which will just find out the middle value, right? And there is one more condition in the median is that the data should be sorted. Sorted means the data should be in the ascending order or descending order, you can say. Then only you have to find the middle value, right? Okay, let's come to the mode now. What do we know about the mode? Most common number in the list. Yes, correct. 1, 2, 2, 2, 3, 4. Here the mode is 2 because 2 occurred 3 times, so we can say this is all right. Now let's move to the next one. Let's come to the standard deviation. First, we will do the a little bit of definition. What is standard deviation? Because this term is used too much in the machine learning, so we should know it. Standard deviation is a number that describes how spread out the values are. So a low standard deviation means that the most of the numbers are close to the mean. And the high standard deviation means that the values are spread out over the wider range. This time we have registered the speed of 7K. Okay, let's forget. Standard deviation. I want to show this with the help of a graph. Okay, let's keep it very simple. Suppose we have some numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. If we will do the sum of all the numbers, it will be 55, and if I were divide it, it will be 5.5, right? So the mean is 5.5. But if I calculate a standard deviation for this number, it will be 4.5, and for 2 it will be 3.5, for 3 it will be 2.5, for 4 it will be 1.5, for 5 it will be 0, 6 now it will become here, for 7 it will go here, 8 go here, and 9 it will go here, for 10 it will go here. So you can see the most of the values will lie in this region, right? So you can see, basically what we can say, the deviation means the moving of forward and backward, that is, from this you can figure out that how your data is moved, right? So according to this, what do you want to say? Is it a low standard deviation or high standard deviation? Any answers? High, yes, we have very high standard deviation, right? Now suppose our data is, you can say, 2 3 3 3 3 2 1 1 3 2 3. So let's assume 5. Okay, let's assume the mean is of the data is anything. Of course, the mean will be 3 only. Okay, and the standard deviation will be 1 in the left side and 1 in the right side. So what do you think? The standard deviation lying between these points are very high or low? Low, right. For this is very low. Okay. So the concept of standard deviation should be very clear to us, because in machine learning we use this term a lot of times. Okay. And there is one more term which we say, standardizing here, right? So this is our standard deviation. We can say we can say this is 3 and 3 here, right? So standard deviation is basically 3. Okay. Standardizing means converting this uh, standard deviation to 1. You have to convert it to 1. Fine. So what we will do, we will divide it with the 3 both the sides, right? So whatever data we get now, whatever graph we'll get now will be the standardized form. So whenever we have the standard deviation of 1, that is called a standardized standard deviation. Okay. So like actually we have to convert our any graph into the standard deviation so that it is suitable to perform the machine learning algorithm. Okay, so this process of converting is called standardization of standard deviation. Okay, otherwise if we'll not do it, it will show irregular pattern in our data. Fine, so it is very necessary to do that. All right. Okay, now there is one concept of percentile. Let me show you. What are percentile? Percentile are used in statistics to give you a number that describes the value that a given percent of the value are lower than. For example, let's say we have an array of the ages of all the people that live in a street. Wait, there is one question over this one that you can see here. So 5, 31, 43, 48, these are the ages of the people living in a street. Okay. So what is the 75 percentile? The answer is 43, meaning that 75% of the people are 43 or younger. So do you know the meaning of, okay, let's say how to find it, by the way. First of all, let's understand the meaning of percentile. You must have heard about the percentile in a lot of entrance examination, right? Basically, percentile is something which is relative to the moment or people around you. So it is related to that. So if somebody is having age 75 percentile, let's talk about the suppose this is the scores, okay, in which you have performed in a exam. This is scores. So if I say that I have scored 75 percentile, what is the meaning of that? 75th percent of the data is covered. Yeah, this is the meaning. So Nikhil, that is correct. Yes, 75 percentile means that your marks, it could be anything. Your marks was better than 75% of the people's marks, right? Your marks was greater than 75% of the people. Okay, what is the meaning of if I say 95 percentile? Any answers? Please write in the chat. 90% of the data is covered or learned, right? 95% means your score was better than 95% of the people. This is the meaning of percentile. Let me do it in the Google Colab. Google Colab, how to find out the percentile. You all can see my screen, right? This Google Colab. You should, all of you should also open the Google Colab, and whatever platform you use for doing this, whatever your previous trainers has told you to do, you can open it and run a program. First of all, import the numpy. Oh, import numpy as np, and then we will do. So I'm inserting my data, and suppose I want to find which of the age is greater than 75% of the people. So what you have to write? You have to write np dot. We have one function in the numpy which is called percentile. Yes, and you pass the data here, and suppose I want to find the 75 percentile of this data. Like, which is the age of a person which is better than 75% of the people? Not better. In this age, we cannot say better. We can say elder than 75% of the people. 40 is 43 is that age. Okay, what if I do 90? 61 is that age. Okay, so basically, yes, finding the percentile manually is little bit difficult, but NumPy has one function, so we can use it, right? So all of you, please do it, and write yes if it is working in your system. Is it working? Would you please send the array here so the answer will be clarified? Uh-huh. copy paste. Yes, do it very quickly, then I have to cover the next topic. Okay. Okay, tell me one thing. Is so supervised learning and unsupervised learning is done in your class? Supervised learning and unsupervised learning. Is that done? No, I think. Okay, fine. Okay, let's cover the new topic now, which is also very important because we have done the standard deviation, so we should do this also. Okay, normal data distribution. We will learn how to create an array where the values are concentrated around a given value. In probability theory, this kind of data distribution is known as normal distribution or Gaussian distribution after the mathematician Karl, who come up with the formula of data distribution. So what is data distribution? If I say, basically we call data distribution which usually look like this. Okay, so what is this? Basically, if I explain you with the help of diagram. Now suppose I am making a graph of height of the people around the world. Okay, suppose I maybe I have done 10,000 collection of data, 10,000, and I have found out that 5 6 5 foot 6 inch is the mean among the people, and the standard deviation is like this from this mean the data deviates almost around, you can say, 3 inches. uh, then this will become 5.9 inches, and this will become 5.3, right? This will be your data, right? So yeah, this is a natural, right? This is natural. Most of the people will be having the 5.6 or maybe around this, right? So normal distribution is a distribution which is very normal, and we can say and there is only zero point 0.3. The standard deviation is only zero point 0.3, right? So for machine learning, we need this type of data, right? So if your data is very different, you have to convert it in this format. Fine. This is called uh, normal distribution. Can anybody tell me what is the y-axis over here? This is the x-axis. X-axis is the, we can say, mm, yeah, x-axis is the height. Can anybody tell me what is the y-axis here? That is correct. Frequency. You can say the number of people, right? Number of people. Yes, number of people. Okay, just 1 minute. Till the moment I am telling you how to generate this kind of data. Okay. We can create our dummy data by mentioning the number of the frequency. We can put the frequency, we can put the mean, and we can put the standard deviation. By inserting these three values, we can generate any normal distribution data. Fine. With the help of numpy, how we can do? So np dot random dot normal, you have to write np dot random dot normal. Basically, random will help us to generate random numbers, but it should be very normal, right? It should be random, but it should be normal. It means the data should be revolving around the mean. Okay, and it takes three input. You have to give the mean, 5, and standard deviation you can give as a 1, and how many data you want. Maybe 10,000 you can give. And if you see your data, then this will produce a large amount of data. Right now it is just showing a small number of if you check the length of this data, it is containing 10,000 of the data. Fine. So with the help of uh, import matplot.pyplot as plt, what we can do, we can also make a graph like this using our data. So you write plt.hist. Let's pass the data. Everybody please do this, and then I will tell you what to do next. Please try this code. Generate a number. Here we have generated our number, generated data, and here we are visualizing it, means making graph. Please write this code, take your 1 or 2 minutes. Okay. Fine. Okay. All right. Mm, all right. Okay. Uh, one more thing I need to tell you over here is that yes, one more thing is okay. So you see, this graph does not look like this one, right? Do you know the reason? Our graph does not look like this. What's the reason behind it? Used hist. नहीं, hist तो of course we will use hist. This whole data is covered bins. Yes, bins, correct. Bins, what is bins? The size of this bar, right? You have to decrease it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 bins are there and we have 10,000 data. 10,000 divided by 9. How much each, how much each bar is showing? It is showing almost 1100 data. One bar is showing 1100 data. So we better we make it a little bit thin. So what you have to do? You have to write bin is equals to increase the number of bins from 9 to maybe 100. Okay, wait, let me write the plt.show, otherwise this will keep on showing. Later on we will cover this matplotlib, Evon, everything. I think you have done it already, right? Okay, fine. Yes, see this now. Now each now we have, okay, how much now? Now each bar is containing how much data? 100 data only. And we can see there is more accuracy now, right? So this is, so as you increase the number of bins, which is number of bars, you will see more accuracy. Now don't go beyond it, otherwise it will show complete different data. Okay, the now I want to show you something. Suppose, wait, one more thing. So how do we get to know that this our data is, our data is showing a normal distribution pattern? How to get this? How to know this? There is one rule. Okay, one rule is that hmm, one rule is that after standardizing your graph, okay, after standardizing it, this is one standard deviation, right? We can say this is our first standard deviation. So the first standard deviation should cover, if it is normal distribution, empirical formula, empirical rule. Yes, correct. It should follow how much percent of data it will contain. 68. So this particular region should contain 68% of the data. All right, now let's increase the, if you increase one standard deviation here and one standard deviation here. Now what is the total data it is covering? 95. Good. 95. Okay. Furthermore, if we go till our third standard deviation, 99.7. Yes, correct. 99.7. So we call this rule as a 68, 95, 97, 99 rule. Okay. We call this 68, 95, 99.7 rule. All right. Your normal distribution will be in this range only. Okay, just 1 minute. Hmm. Yeah. Yes. Sometimes what will happen, you will get your data queued like this, tilted towards one kind of one towards one direction. Okay. So what you have to do in that scenario, suppose you have data like 20, 21, 25, 30, 35, and whatever, like till data, and it is showing some graph like, right? This is not normal distribution, right? So how do we convert it to the normal distribution? Anybody have idea? Okay, what we will do the log of each of the item. For example, log of 21. Wait, it's not letting me write. Okay, we can say log of log of 21, and we can say yes, log of other numbers like 25. We keep on doing the log of all the digits, right? And then whatever we get, uh, if we make the graph of that one, then it will be definitely be a normal distributed graph. Okay, so this is the one way. This is how we can convert our undistributed, ununiform data into the normal distribution. There is some more method like a central distribution theorem, Chebyshev. We have a lot of things. So this is the first way. We call it log normal distribution. Okay. Time is almost up, so I would like to wind up the session now, right? Hope you have understood something from it. And yes, of course, this is a little bit deep, but yes, we should have a good knowledge of the mathematics behind the machine learning, right? If you are good at it, so it will be easier for you to understand the concept very well. So yes, in the next session we'll do something else. In the continuation. So till then, bye bye. Have a good day.